Hello, let's look into today's Leetcode problem. Find longest special substring that occurs thrice. 1. So you are given with a string S which consists of all lowercase English letters. So this is just 1 point. So a string is called special if it is only made up of single character. For example, here they have given up an example ABC. Here in this string we are seeing three different characters, so you cannot consider it as special. So that is there. And here they have given us a few other examples. Here this string is made up of only one character, that is D. For this one it's Z, and for this one it's F, so we can term it special. And what they want us to do is return the longest special substring which occurs at least three times. And if it's not possible, then you simply return -1. So let's take an example and observe what they want us to do. So I've already written down an example here. So for this example, uh, what they want us to do is return a special string that has occurred more than three times, and that special string should be the longest one that we have discovered so far. So for this string we can see we have two a's present here, two a's present here, and here also we have two a's present here. So this string got repeated three times, and if you try finding out for some other examples from some other substrings in this string, right, you will end up with this answer only. You will be finding A8 to be the longest special substring that has occurred at least three times. So you all you need to do is return the length of that longest substring. That's it. You might be able to find few substrings that are occurring more than once. That is a single character A. So a single character A is occurring 1, 2, 3, 4, 5 for a total of 5 times, but we want to return the longest substring, the longest special substring that has occurred at least three times. So that's the reason we will be returning the length of longest substring, which is 2 here. Okay. So now let's look into the constraints as well, right? So in this question, we are limited to only array or string of size 50, which means a simple brute force solution will also work for this question. If the constraints were larger, let's say if it was 10 to the power 4 or 5, then we would have, then we would have thought of solving it in big O of n. But here a simple brute force will work. I will try to show you the brute force solution as well as a better brute force solution for this question. So a brute force solution is simple. Like you might be thinking right now, all you need to do is form all possible substring for this given string and count the occurrence of all those strings. And whenever you encounter a substring that has occurred more than three times or equal to three times, then you do comparison and basically store the largest substring's length in your result and ultimately return it. But for an input which is, let's say if the input size is 50 itself, then the number of substrings that you are going to form will be enormous. So it might lead to a TLE, but I haven't coded that solution, so I can't guarantee you that. But a better brute optimal solution for this problem is to store only the special substrings, to only try to find the substrings that are special instead of trying to find. Let's take one more example here. Instead of okay, instead of trying to find all possible subsets, let's say this is one subset or substring, this is one substring, this is one substring, this is one substring, why not only try to find the substrings that are only special? By special, what I mean is A can be a separate substring, B can be a separate substring, C can be a separate substring, A can be a separate substring, and D can be a separate substring, D can be a separate substring. So all you want to do is find out only special substring. From there only we will be filtering out the maximum length, right? So we will only go on do the iteration and store or try to find substring that are only special. So that's what I have done in my code. So let me quickly walk you through the code as well. I'll do the dry run first. Okay. So we have AAB, AAB. So what I'll do is I'll take a pointer here. I will simply iterate through this string basically, and for every I will be trying to find a special substring. So here A itself will be a special substring. We will keep a map actually to store the substrings as well. So for now, uh, we have a count of 1. Now we will have one more pointer for this ith location, and we will check. We can start from here itself. Let's do one thing, or else it's just a dry run. So initially MP of A, the key is basically the substring, and the value is the occurrence is equal to 1. For this I, we will be trying to find other substrings as well. Now we have one more pointer. Now we are pointing that pointer towards the next position. Next position is A as well, which means we will be able to find one more substring starting with the position I. So we are simply going to increase or form a key value for this substring as well. Now we will jump, we'll make a jump, we will move our J pointer one step ahead, trying wanting a possibility to be an A for this position as well, but for this position it's B. So it means that we won't be able to find or make special substrings anymore. So in that scenario, we can simply cut it out. We can increase the counter of I, and we can do a fresh start from here. And for this, we will have only one A. So A's count will be increased by 1. Then we will have J to be here. But okay, let me erase few things. Oops. Now, okay. Okay. Oh, my bad. So right now I is pointing in this location. The value of A is incremented by 1, and J points to this index. Now we won't be able to form another substring here because of you know the substring not being unique. So we increment the I pointer again, try to reset the J pointer again. I will be pointing in this location. MP of B will be equal to 1. J will point at this location. The substring that will be formed will not be having one unique character. So we are simply going to reset the position of J and increase the pointer I. I will be pointing here. A's count will become 3. Then J will be pointing here. A's count will become 2. Then J will jump one step ahead. Now we have one more unique case here whose occurrence will be this, and J will point here. Now the substring that's being formed is not unique, so we reset J, increase the pointer I. Okay, I'll have to remove. It's quite difficult to remove. So I will be. Can I remove this? No. Okay, so now I will be here and J will be here. A's value will be incremented one more time, and I and J again will form a substring with only one character. So this one's count will increase by one more time, and j will point here one more time in the end, but we don't have a unique substring or a special substring basically. So I moves one step ahead, a will be increased one more time, and j again will point in this position, that is the last position. No special substring is formed. Then I will go to the last position, and b's value will be increased by one more time. That's it. So this is our updated array. This array, or basically the map, this map only stores the special substring. And in this map, what we want is we will be checking for the positions, the values that has a value set to 3 or greater than 3. For those values, we will be storing the maximum key length. So here the key is AA, and AA's length is 2. Initially, we will have a result array which has a value of -1, and whenever we find any value, right, whose any value which is greater than or equal to 3, then this is what we will be doing. Res is equal to max of res comma, then the maps value basically, map of key. And in the end, what we do is return the result. So that's what I did here. I declared a map here with string as key and int as value, int being the occurrence. Then what I do is for every I iterate through I iterate for from j for j starting from I, and whenever I find a substring with same index. So initially the temp is 0, and if the temp is 0 or empty, if the temp is empty, then we will simply put the first character in that temp, and going forward we will be comparing the last element for that temp. If the last element is equal to the current element, then we are simply going to append that element to temp and then increase its counter. And in the end, like I said, if you are able to find any key, uh, any substrings whose occurrence is more than 3 times, then you do what I said, that is basically try storing the maximum length of that special subarray that occurs more than 3 times, and in the end you simply return result. So one thing that someone might notice here is we are let's say if you take a very big example that has lot of A's in it. So in that scenarios, if you try looking into many examples, right, then you will have a thinking that why are we storing a very big string? Instead, we can store something like character, a pair of character and its occurrence. So for this occurrence, it's 1, 2, 3, 4, 5, 6, 7. So a special substring which has only a character A and its length set to 7. If we do it this way, right, then our space complexity will be good, and at the same time, I won't uh, I won't comment on the time complexity, but space complexity will definitely improve in this scenario. Actually, the time complexity might or might not increase. No, it might not. It won't increase actually. So we will save on space complexity here. So an updated code that I have written here is ditto as same as this solution. Here instead of storing the string and then occurrence, I am storing the char, its length, the special substring's length, and then occurrence. And I do the same thing that we have been doing so far. And in the end, what I do is I simply return the result. That's it. So it's, I would say it is a better brute optimal solution if we do it this way. This way also works. There is no significant difference, but I might not be right. If we are given with a very big test cases or not, then actual computation might prove it out. But yeah, so if I am wrong with the time complexity on this one, if someone watches this video, fortunately, then please let me know. So that's it for this problem. Thanks for watching. Bye bye.